Hi students, welcome back to ChemOrgChem. In this JEE Chemistry Insight series, we have been exploring the solution for previous year JEE Chemistry exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. This is the question from JEE Main 2025. As per this question, they given one reaction sequence. So as per this substrate react with phosphorus pentachloride under heating, which produce product A, which then react with 3 equivalent of sodiamide in the presence of ammonia, which produce product B. When we do acidify, that produce product C. This product C react with diborane and hydrogen peroxide in the presence of base, which produce product D. So here we are asked to find out the final product structure D, and apart from that they are asking to find out the how many sp2 hybridized carbon atoms present in the product D. Well, let's moving to the solution. As per this question, the substrate, keto substrate, react with phosphorus pentachloride. So we know that carbonyl oxygen has 2 lone pair of electron. In case of phosphorus, pentachloride has 5 chlorine atom. So we know that chlorine atom has more electronegative power that withdraw the electron from the positive center, which makes that this phosphorus feels slightly electron deficient. Therefore, we can mark it as delta positive. Now, oxygen lone pair of electron that attacks the phosphorus center, resulting that kick off one chlorine atom, which produce this following intermediate. Now, oxygen provide the electron to phosphorus center, therefore oxygen get positive charge. At the same time, one chlorine atom also kicked away. So now this chloride ion that attacks this carbon atom, now this biponded electron now move towards the oxygen atom since oxygen has positive charge. So resulting that generate this corresponding intermediate. Now you see oxygen has 2 lone pair of electron. So again here you can see that phosphorus still has 4 chlorine atom. This 4 chlorine atom withdraw the electron. Therefore phosphorus still electron deficient. Therefore this oxygen lone pair of electron now move towards the phosphorus atom. So resulting that kick off one chlorine atom which produce this corresponding intermediate. So because here you can see that oxygen donate the electron to phosphorus center, which makes that oxygen has positive charge. At the same time, here you can see that now there is a double bond in between phosphorus and oxygen. So now this chlorine ion now attack this carbon center. So resulting that cleavage of carbon oxygen bond, this electron now move towards the oxygen atom. So resulting that generation of gem dichlorinated product along with generation of POCl3. So this is our product A. So this reaction is called chlorination reaction. In next step, our product A react with 3 equivalent of sodiamide. Here sodiamide act as a strong base. For our convenience, we can redraw the structure like this. Now, first equivalent of sodiamide, which readily abstract the proton from this carbon. So resulting that this electron now move towards here and followed by kick off one chlorine atom, which generate this particular intermediate alkene. So this reaction is called E2 elimination reaction along with generation of ammonia and sodium chloride as a byproducts. So the another equivalent of sodiamide now takes the proton from this carbon and similar type of reaction here takes place which kick off one chlorine atom. So this reaction also E2 elimination reaction. So resulting that generation of phenyl acetylene. Now, one more sodiamide now takes the proton from this carbon atom. So resulting that generation of sodium phenyl acetylide as a product B. So when we do acidify, which take this phenyl acetylide ion takes the proton from acid which generate phenyl acetylene. So this is our product C. Now our product C react with diborane. So diborane can dissociate two BH3 unit. So this reaction is hydroboration reaction. This reaction generally follows anti-Markovnikov rule. As per anti-Markovnikov rule, hydrogen atom going to add more substituted carbon. In case of this BH2 unit going to add least substituted carbon. As per this carbon is least substituted carbon. Therefore, this BH2 unit going to add this carbon. In case of hydrogen going to add this carbon. So resulting that generation of this particular intermediate, when this intermediate react with hydrogen peroxide in the presence of base, which produce this respective alcohol as a intermediate. So this alcohol quickly tautomerize to produce this aldehyde product. So this is our product D. So this is our final product. So this reaction, I means the conversion of C to D is hydroboration reaction. This is our product D, which is our final structure. Next, we need to find the total number of sp2 hybridized carbon atoms in product D. So in any question, if they ask to find out the hybridization of any atom, you just remember this. First, we need to count the number of atoms around that particular atom, including we need to count the how many lone pair of electrons present in that atom. If our count comes 4, our atom is sp3 hybrid atom. If count is 3, sp2 hybrid atom. In case of count is 2, that atom is sp hybrid atom. So for our convenience, we can put numbering. So here we are asked only for carbon atom. Therefore, first we see the first carbon atom. So first count how many number of atoms around this carbon center. 1, 2, 3, which means that the first carbon atom is sp2 hybrid carbon. And second carbon, you just count the how many atoms around with this carbon atom. So here 1, 2, 3, 4 atoms are present. So therefore, the second carbon atom is sp3 hybrid carbon. Let's moving on. Our third carbon atom. So 1, 2, 3. There are 3 carbon atoms are present. So therefore, the third carbon is sp2 hybrid carbon. In case of fourth carbon, there are 2 carbon atom and 1 hydrogen atoms around with this carbon atom. Therefore, the count is 3. 3 means sp2 hybrid carbon. And similarly, 5th, 6th, 7th, 8. So all these cases are contains sp2 hybrid carbons. As per this, there are 7 sp2 carbon atoms are present in our final product D. I hope this explanation has helped you to understand this question, including chlorination reaction, E2 elimination reaction, and hydroboration reaction. And also we seen that how to find the number of sp2 hybridized carbon atoms present in our final product. So if you enjoyed this session, just give it a thumbs up and share it with your friends, and don't forget to subscribe. ChemOrgChem for much more content like this. And finally, thanks for watching. Bye bye.